Hi friends, I am Nasir Sheikh, Assistant Professor, Channabasweshwar Pharmacy College, Latur. In today's lecture, we are going to discuss our new chapter, that is Rheology. So, let's start. The learning objectives of this chapter, of this beat, are students will able to explain the term rheology, understand the applications of viscosity, describe the concept of viscosity and different terms related to the viscosity. So first, let's start with the explanation of the rheology. Rheology definition is: it is the science that concerns with the flow of fluids and deformation of solids. Actually, rheology is a word which is obtained from the two words, that is rheo means to flow and logos means science. So that it is defined that the science which is concerned with the flow of fluids and deformation of the solids. Deformation means change in the matter, whether it is in shape, whether it is in volume, or both shape and volume. So these flow properties of liquids are important in the manufacturing of the several dosage forms, especially in the liquid dosage form. The examples of liquid dosage forms are simple liquid, gel, paste, creams, ointments, etc. And this system is change their flow behavior when exposed to the different stress conditions. Means the flow behavior changes according to the different stress conditions. Next slide. So the flow property of simple liquid is expressed in terms of the viscosity. Viscosity is the measurement tool of flow property of simple liquids. So the definition of viscosity is: it is an index of resistance to flow of liquids. It means higher the viscosity of liquid, greater is the resistance to flow. For example, groundnut oil, honey, syrup, all are having more resistance than water or alcohol. When it is going to explain on the molecular level, the motion is transferred between molecules of syrup is lower than molecules of water. So after learning this viscosity point, the reflection point is why there is need to study of viscosity in pharmaceutical industry. Let's continue with the explanation of the viscosity. That is, the unit of viscosity is poise. Actually, it is the CGS unit of viscosity. The SI unit of viscosity is Pascal second, but majorly the viscosity is measured in the poise. So the definition of poise is: it is a shearing force required to produce a velocity of 1 centimeter per second between two parallel planes of liquid, each 1 centimeter square in area and separated by a distance of 1 centimeter. It is also expressed in centipoise, which is converted into poise also. Means 1 centipoise is equal to 0.01 poise. The CGS system for poise is dyne per centimeter square or gram centimeters per second. The term which is related with the viscosity and which is useful in the pharmaceuticals, that is kinematic viscosity. Kinematic is also called as absolute viscosity, which is defined as: it is the ratio of viscosity to density of the liquid at specific temperature. The formula is the same as that. The definition is eta divided by rho, means viscosity divided by density, and the unit of viscosity, that is absolute viscosity or kinematic viscosity, are Stokes and centi-Stokes. Sometimes the term fluidity is used as the opposite of the viscosity, which defined as the reciprocal of viscosity. Here are the some examples of absolute viscosities or kinematic viscosities of some common liquids. For example, castor oil having the viscosity of 1000 centipoise, ethanol having the viscosity of 1.19 centipoise, glycerine having 400 centipoise, water is having 1.0019 centipoise viscosity. So after explanation of viscosity, kinematic viscosity, let's see whether it is applicable in pharmaceutical industries or where the viscosity is applicable or useful in the pharmaceutical industry. The first application of viscosity is standards of liquids. The second application which is important as point of view pharmaceutical industries, that is manufacturing of the dosage form, means where the mixing, where the flow of liquid is important, at that place viscosity is important to measure. That's why it is having an importance in manufacture of dosage form. The third application is handling of drugs for administration, which given importance in the administration of drugs to the patients, whether it is from withdrawal of content from container or whether the application of doses from syringes, like suspensions are always given with the help of parenteral dosage form, that is the syringes. Next application is quality control tool to product evaluation. Determination of molecular mass is also done with the viscosity determination, and identification of disease is sometimes useful by the viscosity study, and it is also the model for treatment of diseases. After the detailed information about the viscosity and its application, let's see the flow types. There are basically two types of flow, that is one Newtonian flow and other one is a non-Newtonian flow. These flows we can explain in next lecture. Thank you. Thank you.